All right, everybody, welcome to the video here for lesson number 8, the lesson or second lesson on proving parallelograms on the coordinate plane. So for example number 3 in class, I had you start this in class, and we kind of started to run out of time in some of my classes, so I figured I'd add this to the video for today. So for example number 3, it gives us a triangle called triangle ROP. So the first thing I want to do is I want to graph the points or the coordinates here. So I'm going to start with -4, 0, -8, -2, and -6, -6. Small little tiny triangle here. So we have ROP. Just make my pen a little bit smaller. It seems too thick. So if we go through and connect our points, we want to use a straight edge here whenever possible. I'm just going to try and sketch it as good as I can. We want to prove that this is an isosceles right triangle. So here's my plan. My plan of action is going to be use slope to show two sides are perpendicular. The two sides I'm thinking are OR and OP. I can even say that in my plan. And I'm going to use distance to show two sides are congruent. Again, I think it's going to be OR and OP. Again, my thought process here is to use OR and OP whenever possible, because I think that that's going to be the congruent sides and the perpendicular sides, but we'll see. So first things first, let's find slope. So if I find the slope of PO, so from P to O, and I would actually go from O to P here, so I'm going left to right. Notice the slope of this line is going down, so it's going to be a negative sloped line. I know that already. I'm going down 1, 2, 3, 4 to the right 2, so I'm going down 4 to the right 2, so that slope becomes -2. The slope of OR is going up 2 to the right 4, so that would be +2/4, which is 1/2. Notice those slopes are negative reciprocals. So because you stated in your plan you want to show that they're perpendicular, you then have to say, therefore, triangle ROP is right because PO is perpendicular to OR. That's supposed to say OR. Let's fix that. The next thing we have to do is use the distance formula. So now I have to say, is the distance of PO the same as the distance of RO, or OR, whatever you want to say here? So the x values of P and O are -6 and -8. So now I have -8 minus -6 squared, plus the y values, which are -2 minus -6. Just watch your signs here. If you plug that all into the calculator, you wind up getting 20. So you get the square root of 20. Now, all I'm trying to do is show that RO gives you the same exact number. So I don't have to really break this down or plug it in my calculator or anything like that. Even though we could do all of those things, we don't have to. Same thing with OR. So I'm going to wind up having -8 minus -4 squared. And I'm going to have -2 minus 0 squared, which also gives me the square root of 20. So because both of those segments are the same, I then can say, therefore, triangle ROP is isosceles because PO is congruent to RO. The second part of this question asks you to determine the coordinate of point E that would make this a square. So to make sure that this is a square, I need to make sure that all four sides are the same distance apart from each other and the slopes are perpendicular. So you see how from O to R I'm going up 2 to the right 4? Well, if I go down 4 to the right 2, I should wind up being at point E. because that gives me up 2 to the right 4 from P and down 4 to the right 2 from R, making sure that it becomes perpendicular. So point E winds up being the coordinate -2, -4. I'm not randomly guessing where it is. I'm using the idea of slope to do that. Now, to prove something's a square, I first have to prove it is a parallelogram. Then I have to prove it's a parallelogram with perpendicular sides and congruent sides. Luckily for us, we've already done a lot of this work. So because it's a new problem here, essentially, I do want to show all of the slopes of all of these lines. So I want to find the slope of RO. I want to find the slope of PO. I want to find the slope of PE. And I want to find the slope of EO. That should be all 4 sides of my square. Now in this square, R to O winds up being a positive slope of 1/2. We already found that one. And P to O winds up being -2. P to E is also up 2 to the right 4, which becomes 1/2, the same slope as OR. And EO also becomes, not EO, EP, that should be a P. EP, no, we have that one. What's the other side we haven't found? RE, my bad. So RE has a slope of -4 right 2, so that's going to be -2 as well, just like the PO slope. So now we can notice that the opposite sides have parallel slopes and the consecutive sides have perpendicular slopes. That's enough information to prove this is a parallelogram and to prove that this is also a rectangle, not quite a square. Because just because it has 90-degree angles doesn't mean it's a square. Squares also have to have consecutive sides that are congruent. So I also need to know the distance of OR, which, hey, I already know is the square root of 20. And the distance of PO, which I already know is the square root of 20. So we don't have to do any extra work here because we've already done it all up top. Then what we can do is we can say our final sentences. So anytime we're proving something is a type of shape, like a square or a rectangle or a rhombus, we have to first say it's a parallelogram. So I'm going to say, therefore, ROPE is a parallelogram because we could even say opposite sides are parallel, right? So I can say RO is parallel to PE and PO is parallel to RE. Now that I know it's a parallelogram, I can then say ROPE is a square. Now, to be a square, we not only have to have congruent angles, we have to have congruent sides. So I have to say 2 things here. So I'm going to say because consecutive sides are both congruent and perpendicular. Excuse my handwriting, got a little sloppy on the bottom. Right, so let's take a look at the homework question. The homework question asks us to prove that this shape is a rhombus, but not a square. Meaning we want to prove all 4 sides are congruent, but these consecutive sides are not perpendicular. So I'm going to need slope for this question, and I'm also going to need distance. So my plan is going to be use slope to show PQRS is a parallelogram. And used distance to show it's a rhombus. And use slope to show it's not a square. So we're going to show it's not a square by using slope. So essentially for this question, you need three sentences. You need the first one that's going to show us it's a parallelogram. Second one to show us it's a rhombus, which is a special type of parallelogram. And then last one to show us that it's not a square. So let's graph it. So I have negative 4, 5, 1, 10, 2, 3, and negative 3, negative 2. Definitely does not look like a square. I don't know what's going on here. Let's see. All right, so we have our sides. I'm going to use my strategist time so it looks a little bit better. And we want to make sure we label everything too. So I have P, Q, R, S. So I'm going to find the slope of PQ, which is up 1, 2, 3, 4, 5 boxes to the right, 1, 2, 3, 4, 5 boxes. So that's 1. I'm going to find the slope of QR. Notice that is going to be down 1, 2, 3, 4, 5, 6, 7 to the right 1. So that's negative 7. I'm going to find the slope of SR, which is up 5 to the right 5, which is 1 again. And the slope of PS, which is down 7 to the right 1. So again, negative 7. Notice opposite sides are parallel to each other because they're the same slope. Then I want to find the distance of each of these sides. So then I have to find the distance of PQ and then the distance of one of the consecutive sides. So the distance of, we'll say, PS. Because I don't have to find the distance of all four. If I could just prove the consecutive sides are congruent, if I already know it's a parallelogram, it makes it a rhombus. So to go from R, not R to Q, P to Q, right? P to Q. So this will be P to Q. This way we're looking at consecutive sides. So to go from P to Q, the difference of the X values winds up being 1 minus negative 4. The difference of the Y values winds up being 10 minus 5, which gives you the square root of 50. Again, don't care what that is. I just care it's the same as PS. From P to S, the difference of the X values winds up being negative 4 and negative 3. And the difference of the Y values winds up being 5 minus negative 2. Which also comes out to be 50. So I've done all the math required for us to write our three sentences. I have slope, I have distance, so now I can say, therefore, PQRS is a parallelogram because opposite sides are parallel. So I can say PQ is parallel to RS and PS is parallel to QR. I know that because they're the same slope. I then can say another therefore. So then I can say therefore parallelogram because now I know it's a parallelogram. PQRS is a rhombus because consecutive sides are congruent. And then I can say, therefore, parallelogram PQRS is not a square because consecutive sides are not, Jesus, it's coming out really bad. Consecutive sides are not perpendicular. So there are your coordinate geometry proofs. Hopefully this video helped. Best of luck with your homework, and remember, you have a test at the end of this chapter.